Hello, everyone, and thank you for joining us today. Welcome to Megger's special webinar series. Today's topic is Relay Test Management Software Training. My name is Michael Fleischer, and I'm the Digital Marketing Specialist for Megger. I'll be acting as the moderator for today's presentation and supporting you on any technical issues or questions for our presenter. On the right side of your screen, you will see a control panel that looks similar to this one. You can submit questions at any time during the presentation by typing in the box highlighted in red, and I will read the questions out during the Q&A segment at the end of the webinar. Additionally, certificate of attendance, copy of the presentation, and link to the recording of this webinar will be sent to all attendees in 2 business days. Our presenter today is Sugosh Kuber, Applications Engineer. Also, to assist with the question and answer session, we will have joining us David Beard, Relay Applications Engineer, and Abel Gonzalez, Applications Engineer. All right, let's go ahead and get started. Thank you for joining us today, Sugosh.
Thank you, Michael. Good afternoon, everyone. I hope everyone is doing well and staying safe. So today I'll be providing this webinar about the training on RTMS, basic and standard features. So I'll start with the software itself. I have PowerDB Lite that is open here. So the first thing that we will discuss today is the communication part with the relay test equipment from the RTMS or the PowerDB software. So I'll choose the test equipment that I have here with me to communicate with the software. And if you are using the Ethernet mode of communication, you can leave these options default. So I have the use Ethernet option checked here with the port information, and auto discover unit is checked as well. Now, when you're using Ethernet mode of communication, you would have to be careful, as in if you have any firewall settings that are enabled or any VPN settings that are active, that may stop you from communicating. So you would have to turn off your firewall settings when you're using the Ethernet mode of communication. So, and sometimes if you're having the IP settings in your laptop or PC with the static IP addresses used, you can uncheck the auto discover mode and enter the actual IP address here. And the second mode of communication is the USB mode of communication. So if you choose that mode, you can uncheck the Ethernet mode. So it brings up this particular box here, which provides the serial port information. So you can choose the right port that you're using for the communication and then proceed ahead to connect to the test equipment. So today I'll continue using with the Ethernet mode of communication and connect to SMRT test equipment. So once you press OK, it brings up this box wherein it is searching or detecting the instrument on the network, the local area network you're connected through. And of course, it shows up the unit already here with the serial number information. And it also shows the last test set that was used. So sometimes it may show multiple units on the area on the network if you have more than one unit in there. So once we choose the unit, it shows up the home screen of the RTMS. So this is the home screen of the RTMS software. On the top left corner, you see that the connection status is shown in the green color. It says it's actually connected. The connection is successful with the test equipment. So let us take a look at the system configuration to start with. So in the hardware tab under system configuration, there are certain operation modes that are available. So the test equipment that I have used today to communicate is the SMRT 3-phase test equipment, which is a SMRT 46D. And that is the reason you see this particular these particular options that are shown here. So the first option shown is 4 voltages and 3 currents at 60 amps each. So it has got 4 voltages. The voltage channels are displayed in the red color and the current channels are in the blue color. And here is the 4th voltage that is displayed. So if you need to use currents in a parallel mode to be able to inject higher value of current, you can choose option second or option third one, wherein you're actually now paralleling first and second current and getting a single current output, which is a high current output from here, YGen 1, and then the second current here is taken from the third current channel. So we have one current channel at 120 amps and the next current channel is at 60 amps. If you choose to use all the current channels in parallel for this particular model, you can inject up to 180 amps for a short duration. So you can see how the three channels are paralleled and you get a single output from here. Now let me choose the fourth option, which is the 6 currents. So when I choose the 6 currents, it shows that the voltage channels are used as the fourth, fifth, and sixth current channel. What it means is that the voltage channels are converted to current channel. So I have 6 currents in total here. So when you work, when you test microprocessor, three-phase differential relays, you would need 6 currents at one time to be able to inject currents on both winding 1 and winding 2. Okay. So the next option here is for the battery simulator. So you saw that there was this fourth voltage that was shown as AC voltage on the home screen. So for you to be able to use that as a battery sim, you can choose the appropriate voltage here that needs to be injected and enable this last voltage as a bat sim. If you don't see the voltage that you require, you can always enter that voltage here in this space. So once you choose that option and navigate back to the home screen, now the fourth voltage is not shown under here, but it is converted to a battery symbol here on the top, and then it's ready to be able to inject 48 volts DC. Now this feature here, max amplitudes per channel, helps when you have a new personnel in the team or who is still trying to learn the software, learn the relay testing using the test equipment, and you do not want anyone using that test equipment to inject a higher amount of current or voltage than what you mention here. So if you mention here 10 amps of current and 150 volts of the voltage, then the maximum amplitude per channel is it goes only up to whatever values you mention here in this field. So that is kind of a safety aspect that is included here. So one of the distinctive features of the SMRT series is that when you work on high burden applications, wherein you have to inject very low values of current, but you need good compliance voltage, at that time, you can use this option. Instead of the standard currents, you can choose a high burden current mode. So wherein the compliance voltage during the standard mode, it goes down to 15 volts when you go as low as 1 amp or less. The compliance voltage increases to 50 amps, so 50 volts, when you choose the high burden current mode. Okay. So there is one of the newer features that was added here in the configurator is to be able to enable or disable the IRIG-B capability on the binaries. So if you enable this, the binary input number 1 on any SMRT model number is capable of decoding the IRIG-B signal or time reference signal from the GPS clock for end-to-end test purposes. So one of the important things to remember in the settings configurator is the display versions thing. So when you click display versions, it displays the information of the test equipment. So starting from the software information, what PowerDB version is installed on the equipment or on the PC, depending on if you're viewing the screen on a display unit or if you're seeing the screen on a PC. So it provides you the software information. And then on the left side, it provides you the model and the serial number of the unit, the IP address, and what features are enabled or disabled for this particular unit. And bottom here, I have a table that displays the generator numbers, the YGENs information, and the firmware versions. So this is important. The reason being, when you contact Megger support with questions about usage of the Megger test equipment, the first thing the support would ask you is this version information, and it's very important to know how you can get there and provide all the information. And here in the Systems tab, you have the option to change the phase angle representation. So if you go back to the home screen here, so you see that the phase angles are represented in this fashion: 0, 120, and 240, the counterclockwise. So we're going back to the settings configurator. It defaults to a 0 to 360 lag, the representation that was already shown on the home screen. So you can change that depending on what kind of relay you're working with to be able to match the vector representation on the RTMS or to that of the relay vector representation. So if you're using a Schweitzer, for example, then you would choose plus minus 180 degrees. And once you select that and navigate back to the home screen, you see that the representation changes to 0, minus 120, and positive 120. And sometimes you would want to make all these changes, and then you don't want to keep changing these settings over and over every time you open up the software or boot up the unit. So in that instance, what you could do is you can save all these settings as default, and then sometimes you may have to change very few settings only to test certain type of relays. Then you could, once you do those changes, you can always restore the default that you always want to show up every time. We also have a couple of options. One is a restore factory, which will restore it to the factory default settings. And the fourth one is the restore factory hot environment, which is the aggressive factory default settings. So with this test equipment being connected, you see that it's in the green color. You can also operate or use this software in a simulation mode. When I click simulate device, you see that the color of the status now here changed to the yellow color, which means I'm simulating the software. I'm not actually connected to the unit now. I was connected before, but you can also use the software, work on the software on the test plans and your tests being in the simulation mode itself. So on the home screen, you can use the home screen for various functions. You can inject voltages and currents for metering or injecting the quantities to the relay. Then you can configure the binaries, the binary input or the binary output for monitoring and breaker simulation. You can perform the pickup tests, manual pickup tests, and some timing tests on the home screen. And there are various other features that I would like to show today as we walk through the home screen features. So if you need to inject, let's say, a current of 3 amps, you would just click on the numbers here and the number pad appears, and you would enter the appropriate number and then press the green icon, and you would enable that particular channel. And once you enable the channel, it's still not injecting this 3 amps of current from the test equipment. It's only enabled this particular channel. So in order to inject the current, you would have to use turn on or off all enabled channels. So once you press this button, it's going to start injecting 3 amps of current. So the nice part of the software is that you can change things on the fly. Now we see that it's injecting 3 amps of current. Now I can have this current channel also enabled even when it is injecting the other 3 amps here, right? So you can just enable, disable, make changes on the fly. Yeah. Now, for you to be able to ramp a value, click on the number you want to ramp and then include that channel in ramping. So now you see a blue colored box that appears for I1 alone. So it means that I1 is in the ramp mode. So I'm using the PC to drive the test equipment, and I'm using a mouse with the PC. So with my scroll of my mouse, I'm ramping the current up right now. You can also use the arrow keys on the laptop or your PC keyboard to control the ramping. So when you use the display on the unit itself, let's say you're not using the PC, but you're using a display on the unit, or it's a handheld display, which is called the STVI, you would have a knob to be able to ramp up or down the values of the currents or voltages that is in the ramp mode. Now, let's say you would want to ramp multiple channels. So what we will do is we will go to the current ramp options, and then we will choose the particular mode that we want to ramp. So let's say we would like to ramp the phase angles, and for all the 3 channels at an increment of 5 degrees per click or per turn of a knob. Right? Once you do that, it puts the blue boxes on the phase angles. Now the phase angles are in the ramping mode. So let us make sure that all the currents are on the same magnitude. So to do that, I would choose this balanced button. So all the current channels show 3 amps and at the phase angles that are shown here, and we'll turn on the voltages as well. So now when I turn on all these channels and start injecting, once I start ramping, you can see the phase angles are changing on the right side here on the phasor diagram as I ramp up or ramp down. So it's very easy and straightforward to be able to set up the ramping on the home screen. And the same rule applies for the currents, frequency and phase angles also on the voltages. So to be able to ramp the voltage channels, you would choose the voltage here, voltage option, and then choose the amplitude and which channel you want to ramp up, and then choose the increment. So the rule applies same for all the attributes here. So far we were looking onto the fault screen on the home screen, like fault window on the home screen. There is something called as pre-fault window as well. So certain relays, they require pre-fault or nominal load condition values to be injected before they can be subjected to a fault state for them to behave accurately. So let us go ahead and set up an example pre-fault condition here. Let's say I have 1 amp of current on the 3 phases and 69 volts voltage, and you would like to inject that pre-fault values for 4 seconds. Let's say for 4 seconds. You can also change this seconds to cycles or milliseconds by clicking on the unit itself. Depending on your preference, you could choose the time unit. So once you set up the pre-fault window, and assuming that we have the fault state with these values here, and go back to the pre-fault. If you press this particular power button here, it's going to inject the values only on the pre-fault and will never run the fault state. So to be able to run the sequence of pre-fault and fault, you would have to use the play button here. Once you start the play button, it will inject 1 amp of current for 4 seconds, timer going backwards. Once the timer expires, it switches to the fault state and a trip timer starts. So it's waiting for the relay to trip. So as soon as the relay trips, it stops the test and also stops the timer for the test. So basically we just did a timing test on the home screen using the pre-fault and fault windows. And once you're done with the timing test, you can add that to the report using the report options. So you can add results to the report. So the timing test that we just performed is shown here in the single page report view. It provides you all the information like pre-fault time that was entered, the pre-fault information as to amperes and voltage, and the fault information, and what was the measured time, trip time. So once you enter the minimum and maximum value for the accuracy of the timer, you would get the pass or fail result based on that. And this is a single page report view, and this is not the complete report yet. And we will later discuss about the report, a complete report later. Okay, so next thing we will talk about is the configuration of the binary inputs and the binary outputs. So you see here we have the binary inputs shown on the top. So if you would like to configure the first binary input, just click on the binary input, and you can rename them if you need to, something like a trip contact or a alarm contact or a close contact, depending on how you need them. The next thing is the input type. Is it a dry contact monitoring or a wet contact monitoring? So we'll use this for the dry contact, and for the wet contact, we will use this kind of a selection. And the next thing is the input action. What kind of action are we monitoring? Is it a normally open to close action or a normally closed to open action? Right? We have different options to select from. And by default, the binary input 1 is being used as strip here. If you need to use some other binary, you would just disable this particular input and then move on to the one that you need to configure. So I'll use this as strip in this example, and that's enabled. The option here is the latch input is enabled by default. So with this option selected, as soon as the contact makes up, when the relay testing is being done, the timer stops for the first contact that is made. If you disable this, it will consider the debounce time that you can enter, especially when you're dealing with electromechanical relays. If you have to provide a higher debounce time to make sure that the contacts are made before stopping a test, you can do so by entering the debounce time here. And this last option here is the auto off volts and amps. So let's say you would want to turn off both voltage and current after a test is done. You can choose that. But let us say sometimes you may want to keep the voltage turned on, but the current needs to be shut down as soon as the relay trips on overcurrent. So during that time, you can only choose auto off current, which means if the voltages are turned on during the test, they would continue to be turned on. You can disable both of them, which means none of these channels will be shut down after the test if you are troubleshooting a particular application. And here, this icon displays that the sound when a contact makes up is not not audible at this point, but you can always toggle back and forth to be able to hit the beep when the contacts are made up. So that is how you can configure the binary inputs depending on the on your need. So if you click this binary input output options, it will provide you with more options to select from. So let me choose the advanced option. So when I choose advanced, it displays more than 3 binary inputs here. It displays up to 7, and then you also see binary outputs displayed on the right side. So the test set that I was connected to earlier had 9 binary inputs, so it would show up to 9 binaries here and up to 5 binary outputs here. So for you to be able to use the binary output, you would simply choose that particular output, and then depending on what kind of operation you're trying to simulate, you would either close the contact or open. So binary outputs are used to simulate breaker status, like breaker operation 52A contact. You would either have this open or close. It's something like a switch operation. So one of the distinctive features in RTMS software is the harmonic waveform generator. So in the harmonic waveform generation, you can generate multiple waveforms on each particular channel here. So when you work on applications like harmonic restraint test for electromechanical differential, or it can be any type of differential transformer differential relays, or if you need to use a certain type of harmonic injection for the application you're testing, you can always use this feature. So if I go to the second waveform here, and I inject, let's say, 2 amps of current, and I can change this frequency to 120 hertz, which means I'm injecting 2 amps at 120 hertz, which means I'm injecting a second harmonic waveform along with my fundamental frequency waveform, which is a 60 hertz at 3 amps. You see that there is this icon that pops up that actually shows that there are more than one waveform that is stacked on top of each other in a single current channel. So let me quickly show you a slide explanation of that. So we have this current channel I1 that I'm using for the test, wherein I actually configured a 60 hertz waveform at first. This is a 3 amps at 60 hertz. And then using the harmonic waveform generator, I also created a second waveform, which is at 120 Hertz waveform at 2 amps. So basically, I have both these waveforms stacked on top of each other on current channel I1 alone. So you don't need to use multiple current channels to be able to inject, harmonic content waveforms onto your application or load. And this icon shows that there are more than one waveform on a particular channel. Similarly, you can create up to 4 waveforms on a single particular channel, be it current channel or a voltage channel. And you can clear all the harmonics if you don't need multiple waveforms. One other distinctive feature on the RTMS software is the fault calculator. So in the fault calculator is very useful when you would have to test, could perform a quick test of a complex function. Let's say it's an impedance relay, a distance element. So you can choose an impedance mode here in the fault calculator, and then you can choose what kind of fault you would like to simulate. Let's say it's a 3-phase fault or a phase-to-phase or a single-phase fault. So let us keep it as a BC fault. And then what kind of injection you would like to perform? Is it a constant current mode, voltage, or constant source impedance? Right, based on your selection, you can then enter the values here. Let us enter healthy values here on the top. Let us say 2 amps at 69 volts. And then we have the fault values that you can get from the relay settings itself. Your reach impedance, your MTA, which is the maximum torque angle, and the current that you would like to use for the constant current mode, which I would leave it at 5 amps. So once you press the green icon, it will change the channel 2 and 3, because these are considered the B and C phases. The currents will be kept constant at 5 amps, and it would change the phase angles and the voltages to be able to simulate the type of fault you just created in the fault calculator. So the fault calculator basically reduces the time, and you don't have to calculate the values by yourself. Let us say you have a single phase fault. It will also provide you an additional field here, wherein you can choose what type of compensation you would like to provide, depending on what kind of relay or what kind of characteristic you're testing. So again, all these options are also available for different modes that is present in the fault calculator. Now we have overcurrent mode for the current applications, voltage mode, frequency mode. We also have symmetrical mode. So symmetrical mode, if you need to inject some unbalanced quantities, or if you have certain symmetrical components that you would like to inject, and that will provide you the actual currents here in the amps, and you can use the symmetrical mode for that application. We also have the power swing mode and the fault location mode. And so let us take a look at overcurrent mode. In the overcurrent mode, it's again, the fault selection is pretty similar, or same in almost all the modes. So you would choose what kind of fault you would want to generate with the healthy values and the fault values. So you see here, you can also choose some harmonic content injection along with your fault values. You can inject up to 3 other multiple waveforms on all the 3 phases here. And when you click this percentage second, you have the option of choosing all the way up to 15th harmonic if you need to inject, choose a particular harmonic to inject. Now let me just choose a particular percentage of second harmonic. Let's say 6% of third harmonic and 8% of fifth harmonic. So the waveform shapes changes appropriately or accordingly based on the changes that I made here. And once you press the green icon, it's going to show this harmonic icon on all the 3 channels, which means that there are multiple waveforms we just created using the fault calculator. So if you navigate to each of these second and the third and the fourth waveforms, it will show you the second harmonic, third harmonic, and the fifth harmonic. So now we did go through all the pretty much most of the features on the home screen. Now let us move on to some of the other features that are present on the RTMS. So what I have here is when you select this new test icon, it shows up a few of these modules or features here on the left and right that are displayed under the standard category and the enhanced category. So in today's webinar, I will talk mostly about the standard features, most of them, and the enhanced features like the synchronizer and frequency and COM trait, they will be covered in an upcoming RTMS webinar, which is the advanced training webinar. So under the standard, let us take a look at the first one, which is the simple ramp feature. In the simple ramp feature, the screen looks similar to the home screen, except that it has additional options that we need to configure on the top of the currents and voltage channels here. So the first thing is we need to choose what attribute are we going to ramp for the element testing. So you can click on the current amplitude here. So you have multiple options to choose from. If you're working on an under voltage relay or over voltage relay, you could choose the voltage amplitude. We have voltage phase angle and frequency, voltage symmetrical components. And similarly, we have the options for the current as well. So if I choose the current amplitude, so I will be ramping the currents, and then I can choose what channels I'll be ramping today. So if it's a three-phase ramping, I'll choose all the three channels. And if you choose these channels here, you don't have to enable these channels here. As once you choose them and when the test is run, it automatically enables those channels and then ramps up, unlike we did that on the home screen. That is one difference here. So once you choose the channels, next thing is we need to choose what kind of ramping are we going to perform. This is a step ramp here that is used for time overcurrent element, 51 element, and we have a pulse ramp that is used for instantaneous element testing, a 50 element. We also have a binary search element, which is a different type of a pulse ramp, which we will discuss in detail as we go through the ramp screen. And we can also configure multiple ramps on the same test. Let us say you have to perform a pickup test and a dropout test on a particular relay. You could create more than one ramp in the same test and then run the test. So let us go ahead with the step ramp selection. So based on the selection, the characteristic displays accordingly on the right side. You can change anything that is on the blue colored font on the screen can be edited, just like we discussed on the home screen. So we can change the expected pickup of the relay. Let us say in my case it's a 6.2 amps. So the start value is 85% of my expected, and it increments at the rate of 0.01 amps with respect to 200 milliseconds per step, and it increases all the way up to 120% of the expected value unless the relay picks up during the test. So you can change these values depending on how you want them to be. So they are defaulted to 85% at start and 120% on you. And the nice feature of the RTMS software is that when you hover the mouse, it tells you as to what that particular field is. So it says it's a start value. It does say it's a dwell time, so the time between each step. So once we have this characteristic selected, then we have to make sure we're using the right binary input that is configured to monitor the output contact of the relay. I'll choose binary input 3 in this example. So we have set up the test, so we'll go ahead and run the test. So when I start this test, it started at 85% of my expected value, and it is ramping at the rate of 0.01 amps on all the three phases. It is waiting for this input to see an operation. So as it's waiting for the relay to pick up, as it approaches close to the pickup point, let's say the relay trips. I'm simulating the contact since we are in the simulation mode. It provides the ending ramp value and provides that value. We can add that to the report. So similar to the timing test we saw earlier, we just added this particular test to the report as well. And you can see it does not show the timing test because this is a single page report view. It only shows this particular test in the screen. So we can change the name of this test. So it shows the actual pickup value that we got during the test. So the expected value was 6.2 according to our setup. So the min and max values are shown here based on the allowed percentage error. So like I said earlier, you can edit this depending on the type of relay you're testing, depending on the relay accuracy specifications. You can always change this value. So based on this, it's going to change the min and max values and display the test result. Now let us go on to the next type of ramp, which is the pulse ramping. This is the pulse ramping. So when you choose pulse ramping, you see that the characteristic changed on the right accordingly for the pulse ramping. So most of the fields are same as in it there were in the step ramp, except for one field, which is the pulse time. So we have additional field here that we need to configure, which is at 200 milliseconds. So the current is being pulsed after every duration of 200 milliseconds, and it's pulsed for 200 milliseconds. And the increment is 0.01 amps between each pulse, and the expected is still the same. So let us say that our instantaneous setting is at 50 amps. And so it starts at 85% of the 50 amp. Let us change the increment to 0.5 amps in our case. So it starts at 85%, pulses all the way at 0.5 amps, the rate of 0.5 amps per 200 millisecond, all the way up to 120% of 50 amps. So this is pretty similar to the step ramp, except for the pulse time. So let's go ahead and run the test. So it starts with 85%, and then it is pulsing all the way up to the pickup of the relay. And once the relay picks up, it's going to stop the test and provide the result. So the pulse ramp is also similar to the step ramp here that we saw. So the third option is the binary search pulse. So this binary search is also a type of pulse ramp, as it changed here a little bit, but the way the method it operates is different than how a pulse ramp would operate. So you see here we have the start value, the end value, the expected, with the pulse and dwell times, but we don't have an increment value, but we have something called as end resolution that is displayed here. So the binary search is very handy when you are dealing with electromechanical relays, wherein you're trying to find the instantaneous setting of the relay. Usually the instantaneous setting, it may be visible on the scale, but it may not be always as what it shows up on the scale. So it needs to be tested many times before getting the accurate result. So that is when binary search comes into picture. So let us take a look as to how this binary search concept works. So let us say that the expected setting in our case is unknown, right? For the electromechanical instantaneous unit, even though it shows up on a scale, we still are not sure about the expected setting that we are testing today. And the end resolution is 0.01. Okay, and I'll explain as to what this end resolution is. So when we use the binary search to perform the test, we are providing a range here, which is, let's say the range of my setting is 1 amp all the way to 50 amps. This is the instantaneous range of the relay. And we know that the instantaneous setting is somewhere in between, but we don't know where it is exactly at this point. So at first, the test equipment injects 1 amp of current to the relay and sees that there is no trip. And then it goes all the way to, and it injects 50 amps of current in the next step. And it sees that there is a trip that it sees, which means we just confirmed that the instantaneous setting is indeed within this range. And the next step that the test equipment performs is it chooses the midpoint of the range, which is 25.5 amps, and injects the current. And it sees that there is no trip. So by doing this particular step, it sees that the instantaneous setting is not within this particular range. It is between 25.5 and 50, because there was no trip at these values when it performed the test. So the new range becomes, as shown here, 25.5 and 50, and then it again picks the midpoint, which is 37.5, and injects the current, and it sees that there is no trip again. So based on this result, it's again going to update the range to the new range, as shown there. The new midpoint now is 43.75, and it sees that there is a trip. So now again the range changes based on this result because there is a change in the result. The new range is 37.5 and 43.75, and so on and so forth. It keeps hitting the midpoint of the new ranges every time it based on the result. Now it sees a trip again, and so on and so forth. It keeps on doing that until it hits a end resolution of 0.01 amps between these two numbers of the range, and it goes up to that accuracy level. So it goes up to this level of resolution and provides the actual trip point of your instantaneous setting. And that is how a binary search works. So in our case, if we don't know the expected, we will click on this particular field here and click no expected, and we will provide a start and the end. Let's say start is 1 amp and end is 50 amps, and rest stays the same. And you can always change this end resolution based on how small you want the range to be. Of course, how accurate you want the range to be as it gets closer to the setting point. And that is how you can use the binary search to obtain the accurate instantaneous setting. So now let us look into configuring multiple ramps. So when you have to configure multiple ramps, you just click on this particular field and set the number of ramps. So in this case, so you can go up to a maximum of 24 ramps on one single ramp screen, on one single test. So in our case, we're going to perform a pickup and dropout. So it shows up two ramps here. So in the first ramp, I have, let us say that I have a current pickup of 6.2 amps, like we discussed before, and we have an increment of 0.1, and start and end is as shown here. So for the second ramp, the start has multiple options. So you can either have start is value, and then you can have either start is percentage of last value and start is last value. So let us say you choose start is last value. What it does is that it takes off the expected field away, because we are saying that the second ramp uses the last value from the previous ramp, which is the first ramp. So a point at which ramp 1 ends, that is where the ramp 2 starts. And now it's going to check for the drop off in this particular test, and it reduces the current. And in our case, we can just put a lower current value of 1 amp. Of course, the relay should drop off before then. And I'm choosing all the 3 phases again for the second ramp as well. We're going back to the first ramp. So if your relay needs a pre-fault, even before you start ramping, you can always enter that pre-fault values in these fields here for the current pre-fault and the voltage pre-fault. Let us say I have a pre-fault value of 1 amp on all the 3 channels, and I would like to run the pre-fault for maybe 5 seconds. So now our test is set up for 2 ramps are set up to perform the pickup and dropout test. So let me start the test. When we start the test, it runs this pre-fault value for the pre-fault amount of time before it starts ramping at 85%. And once it ramps up, I simulated, it's going to drop off now. It's reducing these currents to check for the dropout value. Right? So now once I click the simulate contact, so it shows the last value, and now we can add this to the report. Now we can see that it has 2 ramps that is shown here. So the first ramp is a pickup ramp, and expected was 6.2, and the second one is a dropout. So once you enter this expected, it's going to provide the result for both the ramps. Right? You can always change the name of these ramps to pickup and dropout. So So that is how you can configure multiple ramps on the simple ramp screen, and to be able to use the pre-fault injection along with multiple ramps. Let us move on to the next feature under the standard features, which is the advanced ramp feature. It shows the same information from the simple ramp from the last time, and hence it is showing the two ramps here. So I will choose a single ramp for demonstration. So we have single ramp here. The advanced ramp screen, it performs a similar type of function like the simple ramp screen, except for a couple of changes. So the one thing is that you can ramp multiple attributes on the advanced ramp screen, and that is why it is called as advanced ramp. So the look of the advanced ramp screen is also different from the simple ramp, wherein you can see that there are windows for each step. Like for a pre-fault condition, there is a separate window where you enter the pre-fault amplitude and the pre-fault time, and then you can go to the start value and you can change the start values of any of these channels and move on to the ramp increment window, where you can increment only those values you need to be ramped up or down, and rest of them will stay at 0. And the last window is the ramp end value, which is the 7.44 in our case. If we go back to the ramp increment, you see that we have a field for dwell time for us to update. That is because we have chosen this step ramp type for the advanced ramping in this case. So there are multiple ramp types again. One difference from the simple ramp and advanced ramp is that to be able to perform a smooth ramp. So let us go through the step ramp before we move on to the other types of ramping. So let me go ahead and change this to 0.02 so that we can slow down the ramping and to be able to see the actual ramp. You go ahead and press the play button. So it is having 1 amp at for 5 seconds as a pre-fault, and then switches to the ramping from the 3 phases. You just stop the test. And every test screen you get, you can, after the test is performed, you can always add them to the report. So this was a simple step ramp on the advanced ramp screen. So the smooth ramp is used when you would have to perform something like a rate of change of an attribute, like a rate of change of frequency element. You can use a smooth ramp. So the way the smooth ramp works is that you can have the pre-fault condition, and then you have a start value, but in the increment window, we have something called as, you have a rate of change per second. So that is what defines as to how smooth your ramping will be. So everything else stays the same, except that you don't have a dwell time. You just mention the rate of change of current here in this case, and then we have a stop value here, which is pretty similar to what we have with the step ramp. And the same is the case with the pulse ramp as well. The only difference between the pulse ramp and the other 2 ramps is that in the ramp increment, you have the additional field of pulse time, just like we saw in the simple ramp screen. And you can always navigate back and forth between the advanced ramp and a simple ramp. You can also display certain metering data based on the setup. So let us go back to the step ramp here for a second. So we have these fields that are turned on. We have 3 currents and 3 voltages here. So if I choose this advanced option here, and let us say I display face-to-face voltages, it's going to display the face-to-face voltage metering data, and as our voltages, if at all they change during the test, it's going to display this metering information here. We have multiple options to choose from. You can display the symmetrical components metering, depending on what is being injected on currents and voltages, the power data, impedance data, and also the secondary values. And you also have these options on the home screen as well. when we looked into the advanced options for the binary inputs and outputs, you have the same options on the home screen as well to be able to display any of this metering information. Now let us move on to the next feature under the standard, which is a timing feature, the overcurrent timing feature. So once we choose this particular feature, next thing we need to do is tell the software what kind of relay we are testing today. Is it electromechanical relay? And if it's yes, then we choose that, and we also get an option to include target and ceiling tests. So once we choose the options, we can choose and pick and choose multiple tests on the screen. You can then update the tolerance based on the type of the relay. If it's electromechanical relays, the tolerance will be pretty higher compared to microprocessor relays. So based on that particular relay specifications, you can update this min and max tolerances. We also have the absolute error if you need to use them, wherein if you can use them along with the min and max percentages. We also have the blinder tolerance, because you can set up a directional test on this particular feature here. So we have the option for blinder tolerance as well. That's 5 degrees. And after the tolerance area, we have the test area wherein you can edit the pre-fault condition values. So for how long do you want to inject a pre-fault, if at all you are planning to inject some pre-fault before every test? And what is the pre-fault value you need to enter? And then the post-fault time. And what is the maximum time you need the pre-fault to be turned on? And the connection of the PT, what kind of connection it is, either Y or open delta. So on the time current curves, it's very typical that we see the plot is versus multiple of test currents. This is what is usually seen. But if you choose to change this, you can change it to plot versus current. Instead of the multiples themselves, it will actually plot them with respect to the exact current. So you can change that setting here. And once we choose all these settings here, we'll move on to the next screen. And since it's electromechanical relay, I'm going to choose a single phase fault that I'm going to simulate. It's a phase relay. And next thing we need to choose is what manufacturer relay we are going to test, and what is a time current curve, what is the model type. And so in this example, I'll choose a ABB Westinghouse, a CO type relay, and let me choose a CO9 as an example. And then we will update the tab setting, the pickup, and the time dial. And we'll also input the instantaneous setting if we know them from a previous test report. We'll update the delay to 0 here. And then the reset time is very important when you're working with electromechanical relays. So we provide adequate time for the disk to go back to the original position before start of each test to be able to get accurate results. Right? Again, you can change these to cycles or seconds, the units of these times. And the ceiling information can also be updated if it's 0.2 or 2. And depending on the type of test you're performing, if you need to apply pre-fault, you can leave this option selected. So I'm going to uncheck this since I don't need it in my case. Use phase compensation. This option is useful when you are working with a 3-phase microprocessor relay or a 3-phase relay, and then you're trying to simulate a single line to ground fault. So at that point, you can use the phase compensation. But for the electromechanical relays, you don't have to use the phase compensation. Once we have all the settings entered here, we'll move on to the next screen. And the first screen that shows up is the phase pickup test. So we saw that we performed the pickup test on the home screen by manually ramping. Then we also saw how we can perform the pickup test using the simple ramp or the advanced ramp screens. So we can also perform this pickup test using the timing screen, since this automatically creates the test based on the settings we just entered. So since it is electromechanical disk-based relay, this pickup test is already having the 3 stages of test. So let me run the test as I explained them. So it starts with 2 times your pickup to close the disk, and then once the disk is closed, it reduces the current to see the disk dropping off just a bit, and as soon as the disk drops off, it's going to increase in a finer increment to see when the disk picks up again and makes the contact, right? And at that third stage, it's going to stop the test and provide you the accurate result. So again, you have multiple screens or multiple ways you could perform the pickup test, like the home screen or the ramp screen or the timing screen. Now on every test screen, you have this option to choose different binary input. You can choose it based on your connections. So now let's change the test and see what other tests are created here. So we ran the pickup test. We have a phase timing test, instantaneous test, and target and sealing test. These are the 4 typical tests that we would run into when we are working with electromechanical overcurrent relays. So let us look into the phase timing. So because we chose this manufacturer and this particular model, it shows that curve that is present here in the RTMS software based on the selection. It also shows the instantaneous on the time current curve, since the instantaneous was 45 amps, which falls at this particular multiple of current. On the left side, it shows multiple tabs or multiple points that is actually editable. If you need to change these multiples, you can do so by clicking on them and changing those numbers. So it automatically changes on your curve. If you need to add additional multiples, you can do so by clicking on this empty field, and it creates the multiple test point. So you can add multiple test points in the table depending on how many of test points you need. So you can also change the test current. Let us say instead of changing these multiples, you would like to change the test current. If I enter this as 13 amps, it changes it to 2.1 multiple and changes the point appropriately. So since these time current curves are present in the RTMS curve library, it's going to update this min and max time depending on the curve that was built for, and also it depends on the tolerance that we first entered as soon as we open the tolerance setting for the timing screen. Let's go ahead and run the test. So it starts with the first multiple at 13 amps, and it waits for the relay to trip, and it waits for the 10 seconds reset time for the disk to get back to the original position. And then it starts with the second test. And so on and so forth. It does that for all the points, and it resets after every point so that we get accurate results here. Well, my relay tripped earlier than it was supposed to. So that is the idea of using the phase timing test. Since we saw all these points, I'm not going to run all the points for today's example, but that is the idea of how you can use the phase timing screen to perform a time current curve test. So let us say you don't want to run all the points. Let's say you want to rerun a particular point alone. You would just choose this particular item number, and then you can run that particular point alone. So it's only going to run that particular multiple and not run from the start again. So if you need to run remaining points, not the one that is chosen, you can do so. You can remove a test point, and you can delete the results and rerun the test. So any test that is run on the timing screens, the phase timing pickup, phase timing test, or a phase pickup test, or any other test that is run here on the screen, they are automatically added to the test report. You do not need to add them manually. So it's already there in the test report. So let us move on to the next test, which is the phase instantaneous test. So this phase instantaneous again is already set up. We don't have to set anything up. It's set up based on the settings we just entered, and it uses the regular pulse ramping technique to build this test, and not the binary search. If you need to use the binary search option, you would have to go back to the simple ramp feature or simple ramp screen. And once you run the test, it's going to start ramping at a lower rate than the setting, and then trips where the relay trips. It stops where the relay trips. And the last test is phase target and sealing test. So this test is kind of semi-automated. wherein the user has to simulate contact when there is a salient pickup or salient drop off that happens, because there is no way that we would be able to tell to the test set that the salient has picked up using any of the binaries. So it provides the instructions here as to which channel is being used as the AC source and the DC source. So we would make those connections, and once we make the connections, we'll start the test. So it gives a message saying simulate contact when the relay operates. So it injects a higher amount of current so that the disk moves all the way to close the contact. And once the user sees that, you need to click simulate contact, and the DC starts to ramp up. And once we see a salient picked up, we are going to simulate again, and then DC starts dropping off, and we are waiting for the salient to drop off, and then it's going to stop the test. So this is the only test that is kind of semi-automated when compared to the other tests that were shown in this particular timing screen. Now let us go back to the setup screen here, and let us take a look at one of the microprocessor relays as an example. So we're going back to the tolerances, and let us say that we are testing a microprocessor relay this time, not electromechanical, and we'll proceed further. And we can always change these element names. Let us say you have multiple elements that are enabled on a microprocessor relay. Like you might have multiple levels of 51 itself, 51P1, right? And let's say you have 51P2 as well. So you can click on number of elements, and then you can increase the number of elements on the timing screen to include those many elements here. You can go up to a maximum of 20 elements, right? You may have a ground elements enabled or a neutral elements. So you can choose as many elements you need, up to 20 elements, and then configure them. So let us choose a microprocessor relay as an example, SEL in this case, and I will choose the curve, which is a U3 curve, and I'm just choosing a single phase fault, or you can choose a 3-phase fault as well. So that is for 51P1 alone. Now we'll do the same selection for 51P2 as well. I can change the name here because this is the second element that is enabled, and we need to choose the manufacturer and the curve type. So we did set up multiple elements here. So once you set them up, again, the tests are automatically created. So if you look into the test list, you see that there are 3 tests that are created for 51P1, and 2 tests are created for P2, because we did not have an instantaneous setting enabled for the P2 in our example. So you see these many tests are created. So we would choose the respective test and run that test. Let's go back to the settings screen here again, and let us take a look into the directional element. So if you need to configure a directional element, you would choose the direction if it's a forward or reverse, and then it provides more options for you to enter data into. So it provides the MTA field. You can enter the MTA setting, and the blinder, the type of directional element that relay has configured, and then you can also change the step. So the step increment is the phase angle increment here when the directional tests are performed. So you can change that value here. If you want it either more finer or more faster, you can change that. And one important setting is the reference voltage, or what we call as the polarizing quantity. So you can choose, you have multiple options to choose from depending on what quantity that particular relay is expecting to see as a polarizing quantity. You can either choose a line to neutral, or phase to phase, or a zero sequence voltage. So let's choose the phase to phase. Let's say I will provide a particular voltage amplitude required as a polarizing quantity. And once you have these settings set here, we'll go and take a look at the directional test. So that test will appear along with the other tests here in the list. So you see that the A-phase test and the 3-phase test both are set up here depending on our selection. So you can pick and choose which test you can run. So I'll run the single phase test. So it's going to check for the blinders on both the ends. So it's going to ramp the phase angle, and as the plot is inside the operate zone, the relay is going to trip. And it's going to check on the other side of the characteristic as well, since this is our operate zone and here is our restraint zone, and it is checking on the boundaries of the characteristic here. So as the relay trips, it's going to provide you the actual angle that it was tested for. Right? So that is how you can set up the directional test on the timing screen. So the next feature that we're going to discuss is the state sequencer feature. So the state sequencer feature looks very similar to the home screen, except that it has a few more selections that you can make here to be able to create multiple states on a single screen. So since we can create multiple states and run them as a sequencer, this feature is called the sequencer module. So this feature is useful when you have to test a reclose element on a relay, or if you have to perform end-to-end testing, or if it's a breaker failure element testing, or any other application that requires multiple stages of injection or multiple states of injection. Yeah. So it has a field that is shown here, which is called as maximum states that you can configure here, and that is shown as 7. So of course it defaults to 7, but you can always change this number. The maximum states you can create on this screen is 100 states. So since the sequencer has a default test set up for a 2-shot reclose test, it has maximum 7 states as 7 here. So if I click on this particular state 1, it shows those 7 states as to what names of those states are. And all these states are created inside the single screen. Right? So this whole sequence of states can be run multiple times depending on the need or your application. So if you need to run the same set of states more than one time, you can increase the iterations here, and it will run for those many iterations once you press the play button. So let me choose the binary options here so we can view all the inputs and outputs. So this type of display for binaries, you don't see that on home screen or any other screen. It is only seen on the sequencer screen alone. And what this means is that none of these binary inputs are being used in this state number 1. Okay. And every state, the name can be changed here. You can navigate back and forth between the states using these arrow keys or arrow buttons. Each state actually waits for a particular condition, and that condition is defined in this particular area here. So for example, state number 1 waits for this many milliseconds. So it waits for 1000 milliseconds before moving on to the next state. Okay? That is how this test was created. So let us look into the different wait conditions that is present on sequencer. So the first one is the wait milliseconds, which we saw. It's straight away, it just waits for that much time and moves on to the next state. Wait cycles is similar to the milliseconds, only the unit is different. It waits for so many cycles before moving on. Wait any continue. If you have this option selected, let us say that we have binary input 1 and binary input 3 that is configured to monitor a couple of contacts. So it will wait on either any of these contacts to see an operation before continuing. And you also have a timer to be able to decide when it should continue. So we'll take a look at that as we move through each state here. So wait any or wait all continue is that all the binaries that are configured here must be seeing a change of operation before the sequence can be proceed further. That is wait all condition and continue. So wait any and wait all abort is similar to the option that we just discussed, except that if the condition is not satisfied, it would just abort the sequence it will not continue once it sees a failure of the condition. And the end option is chosen for the last state, which is the end state. There are a couple other options that are shown here, which pertains to performing end-to-end testing, which we will discuss in a little while. So let's take a look at each of these states. So let's go to state number 2, which is a trip 1 state. In this state, it's injecting 20 amps of high current because it's expecting a trip on the relay, and you see that its binary input 1 is selected for monitoring that, right? And it is waiting for any of these binaries. Of course, there is only one here, but if you had multiple binaries that were configured, it would wait on any of these binaries to see an operation before moving on to state 3. If that does not happen, it waits for this time to expire before moving to state 3. So since this is a two-shot reclose test, we have 7 states, and here is my first reclose try, wherein there is no current. It's waiting for the reclose, and this time here must be greater than your open interval for that reclose shot. So it is waiting for a close signal on the relay before it recloses, and then moves on to the second trip. So we are again subjecting the relay to a fault to see the second trip, and the same sequence continues. We have a second reclose try, and we have a third trip, and finally we end the test because this is a 2-shot. So let us say we need to change this to a 3-shot test. We need to first change the maximum states to 9, since we need to add 2 more states, and now we need to add information on state 8 and state 9. Right? Until state 7 we have 2 shots already set up. So now what we can do is we can copy paste the information of one state to another, so you don't have to manually enter all the information and set all these binary inputs and outputs. So we know that the last state is state 9, so we will copy this particular state, move to state 9 and paste that. So we have this as end of the test. So we need state 7 as a reclose 3 and state 8 as a trip 4. So let us go ahead and copy a trip state onto the state 8. All we need to do is change the name to trip 4, and we'll go back to copy the reclose state so we can create a third reclose shot here. So we'll go to reclose 2. We'll copy this state, and we will go to the 7th state, which is supposed to be third reclose try. We'll paste it here. We need to change this name to reclose 3, and now we can see that now we have 9 states, which is set for a 3-shot test. Okay. So additionally, what a user can also do is configure certain timers. So we have this timer setup screen wherein you can configure up to 10 timers. You can type in the timer name here, and you can choose a particular start and stop condition for the timer. So we know that the reclose time, second reclose try was on state number 5. So we will stop on that state, and we will start as soon as there is an operation on the binary, which means as soon as there is a trip, our reclose timer starts. So we will change it to start on post, and we will use the number 1 binary here in our case. So this is how you can change the start and stop condition depending on what kind of timers you would like to configure. And you can go up to a maximum of 10 timers. So once you have all this states that the setup, you can press the play button. Let us go ahead and make sure that the IRIG-B is disabled because we're using binary input 1 in our case. Now let us go ahead and run the test. I would have to simulate the contacts in multiple states since I'm not connected to the relay. So once the test is performed, your user needs to add this test results to the report. So in the report for the sequencer test, it provides information on each state that was created as to what was the name of each state and what was the wait condition, and what were the currents or voltages that were injected in each state, and what were some of the inputs that were used for waiting. So the timers will also show up depending on how you configure them, and there is also a table that shows the binary input and output activity. Since we are in the simulate mode, there aren't any results that shows up, but when you connect to an actual relay to perform the reclose test, you would see the actual test results. So let us go back to the sequencer screen here. So we saw how we can configure the sequencer screen to perform a reclose or a 79 element test. Now let us take a look as to how we can utilize the wait options, the IRIG-B and the POP to perform end-to-end testing. So let us say that you are using a IRIG-B signal that is coming into the binary input 1 on the test equipment. So you would choose this option at the start. So in the state 1, it is waiting for the IRIG signal. And when I press the play button, it is going to ask us if IRIG-B is required, because we had disabled it prior to performing the reclose test. So we are going to enable that. And once it is enabled, it obtains the IRIG-B time from the test set, right? We are having a GPS clock sending a time signal to the test equipment through binary input 1 connection. And here is the current IRIG-B time as an example. So once you refresh that, it's going to provide the actual IRIG-B time at that instant and refresh that every time, right? So based on this, the users on both ends and performing end-to-end can choose a particular time that they want to start the test at. This IRIG-B time for test. You can either enter the time here, or you can set a particular time plus 1 minute, right? So it is going to, if you refresh it and press set time plus 1 minute, it's going to add that 1 minute to this particular IRIG-B time. And once you press the play button on both ends, it's going to start synchronization and start injecting the quantities at the same time. So that is how you can use IRIG-B, wait IRIG-B time for performing end-to-end testing. Now, let us say that you would have to use a pulse, a programmable output pulse, a POP for performing end-to-end. So in that case, you would choose the POP, and it shows wait any continue. The reason it shows this is that it is using binary input 1 to detect the rising edge of that pulse signal that is coming onto the binary input 1 on the SMRT. So when we press the play button, as soon as it sees a rising edge on both ends, of course, it is going to start the test in the synchronized fashion. And that is how I can use the POP and the wait IRIG. And another feature that I would like to talk about is the transient earth fault setup. So transient earth fault setup is primarily used for testing relays that are the earth fault relays that have directional element that are enabled, especially if it's a transient or intermittent kind of fault simulation that is needed to test those elements. So one of the example relays that has this particular element that needs to be tested is ABB REF 615 relay. So in this transient earth fault setup screen, you have two sections, which is a relay settings and the test settings screen. So you can choose multiple options here based on your relay settings. So if it's a transient earth fault or if it's an intermittent earth fault. So, you can choose what kind of zero sequence voltage signal you need to select for performing the test. Either is a measured zero sequence or a calculated zero sequence from the three-phase voltage information. directional mode if it's a forward directional mode or a reverse directional mode, right? You can also display the characteristic if you click on the display zones. And on the right side, you can enter some more information based on the relay settings, if it's the operate delay time, and at what point I would like to start the voltage values in the test, right? And peak counter limit and minimum operate current based on the relay setting. And so the test is built based on these test settings as well, wherein you can provide how many transient states you would like to simulate and what is the fault duration for each transient state. In our case, it's 10 milliseconds for each transient state, and the peak fault current and peak fault voltage that needs to be used. Also, the nominal voltage and current depending on your CT-PT ratio that is shown on the relay settings. So once we have all this information entered on the TEF, it provides an instruction saying, please connect your V1 to the VO of the relay, because we are going to inject the zero sequence quantity from the V1. So you can see that there are 5 states now. We had 9 states that were created for a 79 test. As soon as we configured the TEF, we have 5 states as maximum states. So the first state is a pre-fault, and followed by a transient fault 1 state. So it's the first transient fault state where you see the voltage and the currents here, and that is for 10 milliseconds as we set them up. And the third state will be your load state, nominal state. And again, this is a second transient state because we set it up for a 2 transient states that needs to be simulated. And the last state is post fault. So this is how you can configure the TEF on the sequencer screen. And again, like the ramping screen and the home screen, any test that is performed on the sequencer needs to be added manually to the report, so it is shown on the actual report. The next feature we're going to talk about is the differential feature. So we'll navigate here under the standard and move on to the differential. I'm going to choose a transformer differential screen to provide the explanation. So on the differential screen, as you can see on the upper side of the screen, we have a transformer that is shown with the CTs and the relay, differential relay. So you can update the transformer information, the primary and the secondary values, voltage values, the CT ratios on both sides, and the MV of the transformer, and the transformer winding type. So I'll choose an example of DY1. So depending on all these values, the screen calculates these primary values on the transformer windings and also the secondary values, which are the taps. So you can always verify these values from the certain relay settings show you the actual tap, wherein you can actually verify these tap numbers with the setting tap numbers to make sure that the values you entered are correct. So we also show something called a single phase pickup factor. So by default, it's shown as 1.73 for winding 1 and 1 is winding 2. So these numbers are very important when you perform the single phase test on a 3-phase relay. So these numbers vary from the manufacturer to manufacturer, and sometimes a model to model under the same manufacturer. So the user has to make sure that these numbers are correctly used as per the manufacturer recommendation. So on the home screen, when we looked into changing or converting the voltage channels into current channels, we went into settings configuration screen, chose the appropriate setting to do so, and we saw how the voltage channels were converted to current channels. When you use the differential screen, you do not have to do that yourself. The screen does that for you. It automatically converts the 3 voltage channels into current channels and uses one set for winding 1 and the other set for winding 2. If for any reason you need to swap these channels for the winding 1 and 2, you can simply click on this connection, which means the 4, 5, and 6 current channels, which are the converted current channels, are used to inject for winding 1, and 1, 2, 3 are for winding 2. Okay. in the second half of the screen, we need to update the differential relay settings onto the RTMS, right? So some of the settings that we need to update is the pickup setting, which is in per unit. So my case, it is 0.44 per unit. The next setting is second harmonic content, is 15% in our case. So you need to change that based on your relay settings. And the next setting is nth harmonic content. Sometimes you may have a fifth harmonic setting that may be enabled on your relay. You can choose fifth harmonic and enter that harmonic content setting here. The next setting that needs to be changed depending on your preference is the harmonic ramp mode. So right now it is set to ramp from operate to no operate for a harmonic test. So if you change it, if you click on this field, you have multiple options. You can choose ramp to operate, wherein you see that the harmonic content moves on from a no operation to operation as it ramps up, which we will walk through. On the right side, you see that there is a slope setting that needs to be updated. The restraint equation needs to be selected. So if you click on this restraint equation, there are multiple equations that are shown that are most commonly used in the relays that are for different manufacturers. So we have provided the most commonly used here. So you would choose the appropriate restraint equation for the relay you're testing. And again, these equations can vary between different manufacturer to manufacturer. And like I mentioned before, even between different models under the same manufacturer. So user has to be careful when choosing these restraint equations. And the next setting is the unrestrained pickup, which is 8 per unit. And the table displays the slope 1 and 2 information. So you need to update the slope 1% and slope 2% and the breakpoint. So once you have all this information entered on the differential screen, we'll move on to the next screen. So it starts with the stabilization test. So to see the list of tests that are created in the differential feature, you can click on change test. So it lists all the tests that were created based on the settings we just entered on the nameplate. And we'll walk through each of these tests in a moment. The first test is stabilization test. Let's go ahead and disable the IRIC-B. In the stabilization test, the way this test is built is that once I start the test, it's going to inject these quantities that are displayed under the injected currents columns on winding 1 and 2 at these respective phase angles. So, and the software is expecting us to read these quantities, which is 100.4 amps on winding 1 relay metering and 836.74 amps for the relay metering on a winding 2 current. And this is what is expected for magnitude metering and the phase angle metering. So the user needs to look into the relay metering, and depending on your preference, you can update the values here on this field that are currents observed from the relay. And the phase angles can also be updated. Once you update these values, you could also observe the restraint and the operate metering, the differential metering on the relay. So in this case, since we are injecting a nominal condition, or what I call as a balanced condition, there is no differential condition here, we would not see any trip, which means the operate would be close to 0 or on a very low value. And that is what we need to verify on the differential metering screen. So the reason we run the stabilization test is that to make sure that when we inject this balanced set of currents, the relay must not trip on differential. And that shows that the values that we entered, or the way we configured the differential screen with respect to the relay settings, is correct. The second thing that is confirmed is the connections that you made from the relay test equipment to the relay winding 1 and 2 terminals. So since we also have the phase angles coming into picture, we need this also makes sure that the connections are correct and they're not swapped between the phases. And that is the reason we run the stabilization test. And the next test is the timing test. So in the timing test, the way this test is created is that it injects internal fault onto the relay for a very short duration. So, and its test happens very quickly. So it injects internal fault for, it's like a single phase fault and a three-phase fault, and it expects the differential logic on the relay to operate very quickly since it sees an internal fault. But in my case, since I did not simulate, or I was not connected to any relay, it did not see any operation, and it says that the relay failed the test. But the idea behind timing test is to see how fast the differential element picks up or trips for internal fault simulation. The next test is the pickup test. So in the pickup test, you have multiple options to choose from: single phase test and also three-phase test for both winding 1 and winding 2. You can choose one by one or choose all of them to run one after the other. So what we show here is the actual pickup setting that we entered on the differential screen. And there is also another pickup value that is being injected, right? This is the test value that is being injected. So let me run a three-phase test here. So this value is being ramped up, and this per unit is, the amp value is shown as a per unit here. So both these values are being changed. As this value approaches the pickup, the relay is expected to trip, right? As you can see, that the values that were used for the single phase test and three-phase test are different. Now, remember, we discussed about the single phase pickup factor. For the single phase test, the single phase pickup factor was used. So in our case, the tap was 2.51, and that is multiplied with your pickup, which is 0.44 per unit. So my pickup must be 1.104, which this relay is pretty close to when we perform a three-phase test. But for a single phase test, it is around 1.9 amps. So it uses the single phase pickup factor 1.732 that we chose on the nameplate screen to get the actual test value to perform this test. For a three-phase test, it does not use a single phase pickup factor. And similarly, the ideology is the same for the winding 2 tests as well. It uses the single phase pickup factor for that particular winding when performing the single phase on winding 2, and does not use any of the pickup factors for the three-phase test. Next test is characteristic slope test. So depending on the slope settings that you entered on differential screen, it displays that particular characteristic here on the screen, right? So we already validated the pickup point in the pickup test. Now we need to validate slope 1 and slope 2 characteristic. So it instructs us to click in the chart to add test points. So what we are going to do is select a point on slope 1, and we'll select a point on slope 2, and we'll run all the slope tests. So what happens is it selects a particular point on the slope, and it fixes that restraint point. And the test equipment ramps the winding 1 and 2 currents in such a way that the ratio of your operate restraint, which is your slope 1, tends inches closer towards the slope setting. And as the relay gets closer, as it sees closer to the slope setting, the relay trips. Similarly, even for the slope 2 point, it fixes the point of 6.2 restraint per unit, and then ramps up your winding 1 and 2 in such a way that your operate quantity changes. As soon as the operate quantity reaches a point on the slope, the relay is going to trip. So you can select multiple points on the screen to validate multiple points on the characteristic here. The maximum you can select is up to 15 points on the screen. The next test is characteristic short test. So we did validate the pickup, the slope 1 and 2 characteristic here. So the characteristic short test is to validate the regions that is above and below this the lines here. So, and it's also called as a short test because it's a go or a no-go test. So we would click on this chart to add the test points. So I'll simply click a point above this slope 1 and below this slope 2, slope 1, and similarly a point above and below the slope 2. So we are validating these regions now. Once I run all the slope short tests, it's going to inject, instead of ramping from a particular value, it's going to inject straight at these points on the plot to verify if the differential picks or restrains as it's supposed to. So in this case, since there was no trip when it was supposed to trip for these points, because this is in the operate zone of the characteristic, it did not see any trip. The software did not see any trip. So it failed the test for the points above the characteristic. And since there was no trip seen for the restraint zones or region, it passed those tests. And this blue colored line here that is shown on the graph tells the user that any area where the user would like to click here to add a test point, you will not be able to do so, since it tells that it's outside the capability of that particular test equipment. So user has to select a point which is on this side of the blue line here. Next test is second harmonic block test. So on the home screen, we did discuss about usage of harmonic waveform generator. So let me go ahead and run a winding 1 A-phase test. So this test is also using that harmonic generator feature. It's injecting 2.51 amps at 60 hertz and ramping the second harmonic content, which is at 120 hertz on current channel number 1 for an A-phase test. And I had to simulate it since it was closer to the second harmonic percentage. So it displays the percentage of second harmonic depending on where this amplitude is with respect to the fundamental current, right? As the second harmonic reaches closer to the setting of the relay, which was 15%, the relay will see an operation. So let us go ahead and run a 3-phase test. So now the harmonics are created in all the 3 phases, and you see that the harmonic content is reducing. It's from 16.2%, it's going down, since we are ramping down the harmonic amplitude, harmonic waveform amplitude. As it inches close to 15%, the relay is supposed to trip. So that is how the second harmonic test is performed using the differential screen. And this is the last test on the differential screen, which is the nth harmonic short test. So in here, our setting was for the 5th harmonic, percentage was 30% as setting. So this is again a short test, which means it's a go or no go test. So we are performing 2 tests here. One is a harmonic content for no operation. So anytime the harmonic content is more than 30%, which is 35 in our case, there will be no operation on the relay. But there is a second test we also perform for operation, which will be lesser than our setting, which is 25%. So let me go ahead and run all the nth harmonic tests. So like the characteristic short test, it instead of ramping a quantity, it straight away injects 35% of harmonic with the fundamental current and 25% of harmonic with the fundamental current on 2 separate tests for each phase fault simulation, and also for the 3-phase for both winding 1 and winding 2. As you can see that I'm not simulating anything here. It's expecting an operation, so it's not seeing an operation. So it's failing on the test where it's expecting an operation at 25% harmonic, which is the 5th harmonic, which is at 300 hertz. Let me stop this test. So yeah, similarly, it's going to run through all the tests for winding 1 and 2 and provide you the results for the no op and the operation. And in the differential screen, the user need not add the tests to the report, since they'll be already added in the report, just like we saw in the timing screen as well. So the screens where you don't need to add the tests are timing and differential. They're automatically added. Now let us take a look at the reports and some options on the reporting. So we will click on the report options and we will view the report. So it shows the PowerDB test report here with all the information for the relay here. You can enter that or update that. And since we started adding all these tests from the beginning, from the home screen, a timing test was performed. A 51 element pickup test was performed from a RAM screen, instantaneous, and different tests that were performed here. So there are multiple pages on the report here. As we go through the reports, it shows different tests here that were performed from different features that were selected: the phase directional, the sequence test, and the differential test, so on and so forth, characteristic, and the second harmonic. So there are various options you could perform from the report itself. So since you saw this on the single page report view, you would see the same test result on the entire report. And you can also change the name of the test or the min and max values on the report as well. So if you click on this report options, you can choose any of these options to perform appropriate actions. Like you can show some comments, or so you can show some deficiencies. So once you click this show comments, it provides this this field here where you can enter certain comments. Or if the relay was defective, you could enter an information as to what was the reason as to why the relay was defective, something like that. So some other options is you can show as image, and there is an image field pops up here where you can actually paste an image in there. It can be a connection information, it can be an image of the relay, it can be anything. You can view the test notes. Here it also will be displayed. You can delete the results and rerun a test. You can force a particular result table to a new page. We did see that some of these results, some of these tables are half in page 1 and half in page 2. You can always force these tables to go to the next page. And then you can show test group headings or headers. And you can always save these reports as either as found or as left, depending on how you want them to be. So you may want to have multiple test reports, first as found before changing a relay setting, and then change the actual settings and then test it again for the as left settings. There are multiple options here. You can have your company logo displayed here if you want them to be shown on the test report. The test reports, they can be saved as like you have multiple options to save them. So I can save this test report as a file, test file itself, which will save in a PDB XML format, or I can save it as a template. So let us say we created all these tests for a relay type A. I can save this as a template, and when I do that, let us save this as a template A. And once you do that, it's going to save this as test report, a test template. And the next time when you open the test, it's going to not show any results, but all these tests will be saved here. So you can reuse that template and test a similar type of relay on a different substation the next time you would like to test that. So that is the advantage of saving it as a template. So if you want all the results to be saved in a report, you always choose save as option and provide it a name. So now it is not saved as a template, but it stores all the results in that file. Now we can also save this as a PDF copy. On the PowerDB and print it in a PDF format. So it prints all the pages in the PDF format and provides you an option on the top to open the PDF straight from here. So you can open that PDF. You can see that the PDF is already created, and it shows all the tests that was performed. It also provides the information about what test equipment was used and who tested that, along with more information about the test status and what kind of phase angle representation was used. There are a couple other features I would like to talk about before we conclude this presentation today. There's something called as relay setting screen. So in the relay settings screen, you have the option to create new settings. Let's say you're working on electromechanical relay and you would like to create a custom template or a custom test plan. You can create a new setting file here or a settings information here. Or you can also import settings from a relay. It's a microprocessor based relay. So you have the options of reading from a relay. You can connect the mode of communication, the serial cable, onto the relay itself from the PC. And just like how you would do it from a relay software, you can do it from the RTMS as well to read from the relay. We have multiple options. It's a serial and Modbus. And when you choose serial, you can choose what type of relay you would like to select based on the relay you're testing. And you can update these commands depending on that relay model and the passwords if they need to be updated, the COM port and baud rate information, and then you can read the information from the relay. The other options that you can get information onto RTMS from the relay is to be able to import different formats of these files from the different relay softwares. You can import type XREO file, TEAX for Siemens relays. You have Schweitzer RDB text files can be imported. We have ERL Pro option here. We also can import CSV file. If you can get the CSV files out of Multilins and import them on the RTMS. So we have different options to bring in the settings and put them on the RTMS software. So more information on these features and the enhanced features will be presented in an upcoming training webinar that will be conducted in the month of August. Along with the settings, we also have something called as a relay library, wherein we have test plans from different relay manufacturers that you can choose from. So you can choose the manufacturer from here, from the list, and choose what test template you would like to open. So let us say I choose a Schweitzer as a manufacturer, and you would like to open a particular test template or test plan to perform the relay testing. So we will open a SEL 551 test plan. So it will tell that we are loading settings from a template. It will overwrite the existing settings. Let's go ahead and say OK. So once you load the template, it's going to open up the report with the newer settings that was taken from the template itself. So it updates these settings for a 551 SEL 551 relay on the report. So once you navigate back to the home screen, you would see that in the test plan area, you would see that all these tests are displayed now because we opened a template that already has all these tests available for you to run. And these tests are enabled or disabled based on the settings that are presented or they are present in this particular setting screen. So these settings are similar to what you would see on the relay software itself. So you can navigate back and forth between different elements or different groups using these options here. So that is how you can utilize the relay library to choose test plans from different manufacturers. And like I said, more information on using this library and working through the test plan and the settings and more about these enhanced features will be presented in an upcoming webinar in the month of August. This concludes the presentation.
All right, thanks a lot, Sugosh. We'll now take some time to answer as many of your questions as we can. If you have any questions, please submit them now into the Q&A box on the right side of your screen. For those of you that are leaving, if you could take a few minutes to answer the survey that pops up on your screen. On that survey, there's a field where you can also request a demo or a quote on any Megger products. A copy of this presentation, certificate of attendance, and a link to the video recording of the webinar will be emailed to everyone in about 2 business days. You can also view recordings of previous webinars on our website at us.megger.com/webinars and register for our next webinar this Thursday, how to perform battery impedance testing with the Megger Byte instrument. The presenter will be Jason Aaron. All right, let's get into your questions. Our first one I'm going to send over to Mr. David Beard. David, can several configurations be saved?
Yes, and Mike, you can hear me, correct?
Correct.
Okay, good.
Correct.
So yeah, and what we were referring to here is this question came in very early in the beginning, and the configurations was a part of RTMS. When you go to the settings configuration screen, the question came in at that point. So I'm just going off of, can the different styles of configurations be saved? And two, can I save more than one and move back and forward to the between them? So if you were to say configure your configuration screen at the very beginning, you say as soon as you open up RTMS, you would like the voltages to be at 115 volts, then you could set all those and you could save defaults in the configuration screen to allow you to, every time that you opened up RTMS, then it would save it at the 115. We don't have a selection between that you're looking for different profiles, configuration profiles, but what you can do is you can actually save, say you set the save configurations, then you could go at 115 volts, and then you can save it as a PDB XML file and then just reload it each time that you would like to use it. So you can save a configuration file of 115 volts and save 1 amp, and then you can also do it at 69.28 volts at half an amp, and you can set those up as PDB XML files and just load them each time that you want to perform a test. And eventually, when you get to the end of the configuration, then you're actually doing your same test over and over and over. Your configurations follow you each time. So.
All right, thank you. Additionally, David, what is the IP for connecting to the relays?
I wasn't really sure when when this question came in at the beginning what we were actually discussing. So at the very beginning, we were only connecting the IP address we were looking for the relay itself, the relay test set itself. So the SMRT unit was at the beginning was shown when we went through the Ethernet connection. When you selected your device and you were able to show your IP address in there, that's what we were looking for in the beginning. Now to connect to the relay to read the settings out. Sago showed at the last portion of his presentation here and went through the settings and showed that, yeah, there you go. If you're looking at the screen, we're reading settings from the relay. And then as we select it, we're doing SCL serial. In this serial, COM port can be done for the SCL style. Now to do an IP address for Ethernet, it's be based upon what kind of relay you have. Most of the time that will be done through Modbus, unless you have some configuration type that you're using Ethernet with the SCL protocol in.
All right, thanks, David. I got another one for you, though. Can I ramp more than one magnitude at once, e.g. increase the current at the same time as the voltage drops?
Yeah, so what the way we'll do this is you can do this ramp in the current home screen as well. What we can use as an additional feature is the advanced ramp. So in the advanced ramp feature, we can allow you to, it gives you the option to select a current or two currents and two voltages or a voltage. You get a wide selection of what you want to choose in here, and you can ramp all of these values at an increment value at a duration of time between each step. And this will allow us to increase one or decrease the other in here, and also allow us to adjust the time that we want to make each increment and each step as well. So yeah, our best go around is going to be using the advanced feature for this type of application.
All right, thank you. Sugosh, how do I change my time from seconds to cycles in the TOC feature?
Okay, let me navigate to the TOC feature here. So once you set the test up with the manufacturer and information, you can change this in the cycles here for these delays here as well. And once you go into the timing test, phase timing test, you can always click on, it already shows up in the cycles. So you can click on here and change it to seconds, which will navigate back and forth between seconds and cycle. So you can either do it there on the nameplate where we just changed it, or you can also choose it from this table here.
All right, thanks a lot. David, is there anything to let you select open delta PT connections rather than changing phase angles manually?
Currently, there's not an actual selected button that you can choose for an open delta PT connection. You would physically have to make that connection outside of the testing software of RTMS, but also you can you would have to configure that manually as well. You would have to change your phase angles on your 2 voltage channels that you select, and then also you would have to make the physical connection on the test set as well. What I would like to say is we do have an application note for this. So if you would like this application note, it kind of gives you a little bit of explanation on how the phase angles need to be set up using RTMS, along with the connections, that the physical connection that needs to be made outside. Just please let us know at Mega Support, and we will definitely get that to you.
All right. Sughosh, is there a detailed help file where we can find information about the software and how to use it?
Yes, on the home screen itself, there is this help option. And once you click the full help, it will open up the detailed user guide for the RTMS. And also it has some information about the hardware information on the SMRT different units as well. So if you scroll down on this, you have links for different sections that you can click, and it will take you to that particular section. Since this guide is huge, you can also use the control, you could use a control F and then just search for a term that you would like to check for, which is a sequencer, for instance, and you can find that page here and you can get more information on that. So this is where you could get the help file.
All right, thank you. Additionally, Sughosh, can we use pre-fault on the timing screen?
Yes, you can. Let me go back to the timing screen here. Okay. So when you're running the test, you can have this apply pre-fault before test checked or unchecked. If you check them, you're going to see that there is a pre-fault injection happening before the test. Let's go back to the tolerance. You can change the attributes of your pre-fault over here as to how long you want to run the pre-fault for before subjecting that to overcurrent injection, and what is the pre-fault level of injection, and also what is the maximum time that you just want the pre-fault to be turned on in case that the relay does not trip. And you can also change the PT connection here. So this is where you can change the pre-fault parameters.
All right, thank you. David, back over to you. Is there a particular reason that each test has to be manually added versus just having a test automatically added to the report?
No, we only add, so when you want a test to be added, we're only adding the test when you're using the ramp features and the home screen, because you might be doing some, one test after the next, trying to figure the relay out, trying to figure the element out. So in these screens, we automatically just let you choose to add that to a report or not. When you get to any of the other features like the transformer diff, the sequencer, and so forth, we actually go in and add those to the report for you, so you have all that information. So just a difference in thought is, most of the time if you're just ramping something from the home screen, you don't want it to automatically get added to the report, and then you constantly have to go and delete just some stuff that you've been playing around with. You don't want to have to constantly fill up a report with that, or go in and have to try to delete all that stuff out. So we give you the option to add those or not. So.
All right, thank you. Additionally, can we have the demo software?
Yeah, so the software that we're showing today that Mr. Sagosh walked through is free. It's on the Megger website. What you need to do is just go to the megger.com and you can search for the RTMS software in the search screen. There you go. Yep, Sagosh. And then, so on the screen, he's showing where to select it. Select the software, and then as you get to the software, you'll see the download option. The first one that Sagosh is showing is install for the PC. And the second one that shows onboard is actually for our embedded units that have the built-in display. So you won't worry about that software there unless you're actually using it, need to update your software on your units. But whenever you select to download, you will need to create an account and you will need to get that information so it unlocks the download feature here. And then you can use it in simulation mode. Even if you have a test set and you want to use just to simulate, you can just simulate and create tests ahead of time and save those off as templates, and then that way you have a way to do it without always needing the test set there. So you still have full functionality in features and capabilities from our simulated version versus the version that you can connect to a test set with. So.
All right. And speaking of software, can this software, is it compatible with all brands or products?
So what we kind of want to separate this in two pieces. So we're asking software. So if it's PowerDB, PowerDB software integrates with all of Megger products for the most part. We still have sheets and forms, and we have a way to actually look at. There you go. So Ghosh is showing a list on the screen that shows the instrument selection. So PowerDB controls and has multiple test forms for all of Megger products here that are listed. If we are talking about just RTMS software that we were showing today, that only works with the SMRT products and some of our legacy MPRT product as well. But it does not work with any outside of the Megger manufactured products.
All right. Thanks for clearing that up, David.
Mm-hmm.
One last question for you. Is the relay model database updated to include the new relays?
So when we do the updates, or not us, but when PowerDB issues out updates, they update the relay library database that Sagosh, I don't think you showed, but we will be showing in the advanced webinar. When you go into the relay section, then we also have those library or routines or test templates, whatever you want to call them, actually get updated as well. So every time we make an actual PowerDB update that updates RTMS software, then we will actually increase or update that library as well during that time.
All right, thank you. We have one last question, and the question is it possible to provide a phase sequencer example with power swing? And I will answer that. We've referenced an upcoming webinar in August. This webinar, titled Relay Test Management Software Training Advanced, is happening on August 4th. And it's going to cover examples like those discussed previous and the one I just brought up about the phase sequencer example with the power swing. So if you ask that question or have a question similar to that, we're going to be covering that and more on our webinar on August 4th. So please make sure to register for that one. With that, we've gone over time, unfortunately, so we don't have any time left over for additional questions, but we've had so many come in. We are going to follow up with you offline if we didn't answer them online. We apologize if we didn't get to those questions. We have a lot of them we wanted to get to, but we've just blown past our end time. If you could, please remember to take our survey when we close out the webinar. It would really be great for us. We like hearing how we did and how we can do better. That survey will also include a field for you to request a quote or a demo if you're interested. But once again, I'd like to thank you all for attending, and I hope you have a great week.